So welcome to today's lesson on squares and square roots. And today in this lesson we want to be able to understand what a square number and a square root number are, what those kinds of numbers are, and how are they different. So the term square is often used to describe a shape, and in this case today we're going to understand how that shape actually relates to a number, and same thing with the square root number, because they're both based on a shape. So the idea would be is if I actually make a square whose area is 1 square unit, so that little tiny square there is 1 square unit, its side lengths are actually the square root of 1, which is 1, and its area is actually 1 squared. So we could describe the area of this square is 1 times 1, which is just 1 squared, which is just simply 1. Now, the opposite idea of that is the square root. So the area of the square is 1. If we take the square root of 1, in other words, what number squared gave us the 1, we're actually going to get back to that side length of the square. So the square root of 1 is actually 1. It's the root of the square. The root of the square is 1. So if we look at this square's area of 1, its root is 1. So let's look at another example of that, because that one's awfully tiny, and see if we make one a little bit bigger. So let's make a bigger square. I'm just going to work with squares here today. So here's my next square. And if you look at that square, its side lengths are 2, and its area is 4. So if we think of the area of the square is 2 times 2, or 2 squared, then the area of that square is 4. But we can also take the root of the square, and if the square's area is 4, the square root of 4, this symbol is used for square roots, the root of that square, in other words, the side lengths of that square are 2. So when we're taking the square root, we're looking for what number is the side length of the square, or what number did we square to get the 4. So square roots are kind of undoing squares. So you have the one operation that squares something, the other operation that undoes the square. So this is the square root, so the root of the square. So let's do another one, a little larger. See where we're going with this. So if I make the next biggest square on my grid paper that I can make, see that square is a 3 by 3 grid, and the area of the square is 9. So if we're again looking at the area of the square is 3 times 3, or 3 squared, which is an area of 9. So there's 9 squares in that square. So the whole idea of a square really literally comes from the idea of area and finding the area of squares. And the square root is the undoing of that, or if I had a square whose area was 9, what would its side lengths be? Well, it would be the square root of 9, or the root of the square. This is really the root of the square whose area is 9. So the root of the square whose area is 9, square root of 9 is 3. So the square root, that's the side length of the square that has an area of 9. So let's do one more of these, and hopefully we can really cement this idea that if I take any square, regardless of how big or small the square is, and I look at the area of that square by the side lengths, so 4 times 4 is 16, or 4 squared, the area of the square, that is 4 by 4, is 4 squared, or 16 square units is its area. And again, if we take the root of this square, in other words, if we undo the square, if we say I had a square whose area was 16 and I want to know its side lengths, then it's the root of the square. In other words, this number is the root of the square. And in this case, it's the root of the square with an area of 16 square units. So the idea now is that we could really literally go either way with this particular question and ask about squares. Now these are all perfect squares, the square of area 1, 4, 9, and 16. And of course there are other squares that are not in this set, but using grid paper as I'm doing here, it allows us to see these particular ones. So the area of the square is when we take the side lengths squared. The root of the square root, is when we find again those side lengths from the area. So one is a forward operation in some ways, the other is the reverse operation. Like most operations have an opposite, like addition, subtraction, multiplication, division, square, square root. And so we can undo things. And so I'm going to actually put my paper over, and I'm going to continue. Do one more and then just do a little practice with squares and roots. So one more square. Make it a little bit bigger, they're easier to see on the video. And so again, the idea is that if I have any square and I want to know its area, I'm simply going to square the side length. 5 times 5, or 5 squared, which is 25. And there's 25 square units in that square. So that's the area of this square. If I want to start with the area, if I already knew the area was 25, and I wanted to know the side lengths, or the root of this square, then I would just undo this. Again, I'm going back to the root of the square. So the square root of 25 is 5, because that's what we had to square to get that. So I really could simply just make a list of all the squared numbers. So for instance, 6 squared is just 6 times 6. But we also know that the square root of 36 is 6. So what number squared gave us that? And again, just almost making a list of basic squared numbers. 7 squared, the square root of 49, then if I wanted to find the root of the square whose side lengths were 7, then I would know, again, the opposite of any of these. And 8 squared, 64, so the square root of 64 is 8. These are all basic root or square root numbers that hopefully we're familiar enough with to just keep going. 9 squared, or 9 times 9, which is 81. So the square root of 81 is 9. If I had a square whose area was 81, I would know its side lengths are 9. And so in many ways that's the function of squares and square roots. And I'm going to keep going just because these are some handy ones that you should know. It should be straightforward from memory. And again, I'm doing each operation forward and backwards, although forward backwards is sort of arbitrary and make that up. But just if you know one, you know the other. They're just opposite operations. And even things like 11 squared are things that we should know. So square root of 121, when you see that number, you should know that that came from a square whose side lengths are 11. And then 12 squared, or 12 times 12, which is 144. So the square root of 144 is 12. And then get into some trickier ones. 13 squared. So you may not know that one off the top of your head, but it's a worthwhile one to remember because it comes up fairly often. And so if I want to know the square root of 169, I know it's 13. And even 14 isn't so difficult to remember because that's 169 was the one before it. This one is 196. So the numbers, last two numbers just switch. And so the square root of 196 is 14. And then even 15 squared I know is pretty common. And that's 225. And so the square root of 225 is 15. Again, what's happening is if you're finding squares with these areas and we want to know the side lengths, then if we know those perfect square numbers or square, we can find that square root pretty easily, although certainly could use a calculator in some cases. Even a few others that might be worth remembering. 25 squared, so we have that one, is 625. So the square root of 625 is 25. And then you can even, things when you get into the larger numbers are actually not that hard because 30 squared, if you think of 3 times 3 is 9 plus a couple zeros, then you have 900. And so we start getting into big numbers, but they're not that hard to do because we're just looking at these perfect square numbers. And even, let's try 40 squared, because you know 4 times 4 is 16, and so if you got a couple zeros on the end, then we know it's 1600, and the square root of 1600 is 40. And even one more. Some of these big ones seem like they might be difficult, but they're really not once you know the more basic ones, because 5 times 5 is 25 with a couple zeros, and so the square root of 2500 is 50. So look at all those squares and square roots we can do. When we have the one, we have the other. So squared numbers, square roots, really the opposite operations. Now there's a couple of other things about squares and square roots. We only looked at the positive squares and the positive square roots, but there's a whole nother set. Every one of these could have been a negative times a negative. Negative 6 times a negative 6 would still give us positive 36. We just can't show them as an area problem because we don't know what negative areas look like. But every one of these squares and square roots could have also been given a negative answer. So we could actually describe in negative terms or as a negative number. So negative 6 or negative 7 or negative 8 or negative 9 or and so on, because all square roots have both a positive and a negative value, because you can always square a negative and get a positive number out of it. So that's why I'm adding all these negative numbers to my set, because there would be a negative square root for all of these as well. So hopefully now we know what squares and square roots are, and we can summarize the idea of what is a square and a square root. So a square number is a side length of a square area. So really what we're looking at when we're looking at squares is literally a square. It's a squared number. When we're looking at square roots, a square root is actually a side length of a square. So in one case we're looking at the area of the square. Square number is the side length of the square area. And then the square root is the side length of the square. So again, the idea is that square is the area times the two side lengths multiplied together. The square root is the side length that we began with. And so that's how they are defined, or what they are. And they're just, the only way they're really different is that they're opposites. So we could say they are opposite operations. Kind of like multiplication and division are opposite operations. Addition, subtraction are opposite operations. And so that's how we calculate them, and that's how they're used. And we're actually, in the lessons we use these for, we're going to use them as area. So the positive ones are the ones that we will see in this case. And we need to remember that the negative ones do exist as well. And there are some interesting things that happen with squares and square roots as we work through this. So what I'd like to do is add a few questions along the way here in this, and we'll wrap this up. So we have a summary. So if you look at what we've done here, okay, my question would be, what is a square number? And so hopefully you can see over here, a square number is just the side lengths of a square multiplied together. And then what is a square root number? And hopefully again we see that what a square root number is the root of the square, or the side length of the square from its area. So we start with the area and we work to that. And then maybe as we look at all of our squares and squared numbers, we might ask a question like, how do you calculate a square number? So how do I calculate square numbers? And then the opposite of that would be, how do you find the square root of a number? And one last question that we want to ask, and in a later lesson we'll talk about this one, is are all square root numbers perfect squares? And that may not make a lot of sense to you just yet, but so we look at all these, see we have 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. We only looked at the perfect squares, the ones that make whole squares, using whole pieces. But what about other ones that are maybe not quite like this, where you can figure out the number of squares, but maybe not the side lengths are quite so even. Like what if I had a square whose side length wasn't exactly 5? And so those are what we call non-perfect squares. But we can still use basically the same ideas with that. So hopefully now you have a better idea of where squares and square roots, the whole idea of a square root, comes from. And if you think again about the whole idea of a squared number and its root are really literally the same number. They're the side length of a square.